BC Calculus, Lesson 8.3, Volumes. There's a fantastic amount in this, so feel free to pause the tape as needed. Didn't we already do some 3D stuff? And we did. We said here's a cylinder, and we sliced it into pieces. It said if we think about this, the limit as these pieces get thinner and thinner will become more and more like the volume. So we're going to do it differently where we know the cross-section area, and actually not that much differently. And then we integrate from A to B. And we do this is called by slicing, which is what I just showed you above, except it's an infinitely small slice. And it could be like a lampshade. And we take this slice here, that is dx, in this case dy, thick, and we multiply it by the integral of the, make it the other way around, of the area. So that's what we're going to do. That's what we call slicing. And it works. It's out there. So sketch a solid and a typical cross-section. Find a formula for the area. Find the limits, which is a mild hassle, and then integrate. Find the volume. We're going to start with square cross-sections because that's pretty easy to integrate. So here's a pyramid 3 meters high. We're going to draw it so that it's coming right out on the x-axis. And it's going right through the center of the base. I should draw it dotted up into that point, but it doesn't really matter. And it is a base that is 3 on a side. And its height is also 3. So how do we do this? Well, this is with respect to the x-axis. The area is just x squared, because this is 3 and the area of the base is 3 squared. It's going to be the same thing over here at 1 and 2. At 1 it's going to be 1, at 2 it's going to be 4, at 3 it's going to be 9, so it's x squared. We just very simply say the volume is integral from 0 to 3 along the x-axis of x squared dx. This is x to the third over 3 from 0 to 3, which is 9 cubic units, which takes some serious getting used to. In this case, we said it's meters, so it's 9 cubic meters. This is some of the hardest problems you'll see, is figuring out these cross sections. You got to play with them until they make sense. There's no like, oh yeah, that makes sense to me. It's just work on it, see where it takes you. So 2 plus x cosine of x, which is a bizarre little curve. I'll do my best to draw it. This looks like the vase I just drew. It's lying down. We revolve it around the x-axis, so something like that. And it's out here from -2 to 2. So we're revolving this around the x-axis. That means that at any point, the y value here equals 2 plus x cosine of x. The y value is the radius of this circle. If the area of that circle is calculated, it's simply pi r squared. So the integral from -2 to 2, pi 2 plus x cosine of x squared. It's just pi r squared. people get so lost in this problem, and all you're looking to do is find that radius, square it. This is called using discs, which are just circular cross sections. There's no holes in the disc. That would be called a washer. It's just a frisbee without the curvy edges. It's a dinner plate. It's just a disc, a circle. The pie is always going to pop out front, and then the question is, how do I integrate? In this case, I believe we could blast it out and scream and cry and eventually get it, but we will just nint it and get 52.43, which bothers me because it doesn't go to 3 decimal places, but hey, you're out of luck. Cubic units. That right there works, makes sense. It's not too bad, but it needs a lot of practice. You're not going to just look at this and go, oh yeah, that makes total sense. So what's a washer cross section? Well, we'll say, let's find the area between cosine and sine of x. Let's take a quick graph of that. Cosine does this, and sine does this, and it's with the y-axis. We need this point, and we're going to rotate this about the x-axis. So let me desperately try and draw something approximating this. Probably completely wrong. It's not too bad. Shade it? No, I don't want to shade it. It's just going to get it too busy. Almost impossible to see what we're talking about here. Where do they intersect? I believe cosine and pi are equal at pi over 4. What's the area with respect to the x-axis? Which one's on top? Cosine. Sine is on bottom. So you would say pi times cosine of x squared. In other words, give me the whole thing, as if it wasn't subtracting sine of x at all. Oh, but we are subtracting sine of x. Factor out the pi, check it out front. Let's do the volume. Pi from 0 to pi of 4. Cosine squared x minus sine squared x. They call this a washer. It just means it's a disk with a hole in the middle. The hardest part of these problems, far and away, is just remembering to square them. Because we just, okay, I got the function, I subtract the other function, I'm off and running. Yeah, that was when we did area. Now we're actually squaring it to talk about revolving it around the axis. Can we do this one? Actually, we can. Although I would just personally nint it. But the integral, not yet. That's in identity. I believe that's cosine of 2x dx. And that would give us pi sine of 2x over 2, 0 to pi over 4, which would be sine of 0 is gone, pi times sine of pi over 2 is 1, so I'm thinking 1/2. Gives me pi over 2 units cubed. Could have done it with nint, would have gotten the whole 1.57 thing, but yeah. Alright, that's tough but doable. Cylindrical shells does not make sense. It does, but it's just so complicated to view. You're going to struggle really badly to see this. So it's another way of doing the same problem, solid rotation. And rather than saying we cut the lampshade into little thin pieces, we do something else. We do cylindrical shells. And here's the theory behind it. Let's just say the radius here is 2 and the radius here is 1. The area would be pi r squared. You know what, I'm jumping to the end. 4 pi minus 1 pi equals 3 pi. if we're trying to get the area of this whole thing. Well, another way to do it is to say, what's the radius out to there? Well, that's halfway. Radius is 1.5. The thickness of this thing is 1. So 2 times pi times 1.5, and that's the circumference at 1.5, times the whole thickness of 1, gives you, shockingly enough, 3 pi. So you can really do it either way. We're going to do the second way with cylindrical shells. You've been warned. We've got square root of x out to x equals 4. It's wrapping around just like everything else. I'm ignoring that for now. If we look at this as the way I just did it, we say, well, the radius out to some point, and we'll just make a little cylindrical shell, is y. Think about that. It goes up to y. The thickness is dy. Okay, that's it. And then it's the height of the shell. How far is this? That's what makes it hard. The height of that shell is 4 minus whatever the x value is. Since we have dy, we got to change that over. So y equals square root of x. Y squared equals x. Here we go. Volume equals integral from 0 to 4 on the x-axis. And all the dy's and dx's feel flipped to me. 2 times pi, because we're doing that thing, times the radius, y, times the thickness, dy, but we'll do that later, times the height, 4 minus y squared, dy. Wow. Not going to do the calculus for you. You could easily do it. And I'm going off message here. What if we had done it with the shell method? Now it's wrapped around the x, so it's from 0 to 4 on the x-axis. It's pi r squared. The radius out to there is the wrapping around the x-axis. Like I said, I'm going off message here. I'll try it. I might not get there. Pi r squared around the x-axis. Yeah, the radius is just y, so it's just square root of x squared dx, which equals x pi out front. I'll do it all. 0 to 4 of x dx, which equals pi times x squared over 2 from 0 to 4. 16 over 2 is 8, minus 0 is 8 pi. Works both ways. Wildly complicated. You've been warned. You've been warned. So, let's wrap this up. Cylindrical shells. Yay! Gotta draw a picture, otherwise no idea what's going on. Y equals 4 minus x squared. Up 4 and down we go. Stopping it there because we are also told here. And it's wrapped around this axis. We have circles and all that going on in the background. Alright, see if we can do this without cheating. I'll probably have to cheat. We could probably do 2 cylindrical shells, 2 discs if we wanted, but let's see what we can do. We're going to rotate it around this axis, so everything's going to be with respect to the x, which makes no sense since we're going around the y. The radius is here. The height is here. Alright, so this makes me feel like the radius is changing, but we don't have to worry about it. It's just x. So we're doing an integral from, we don't know where, 2 pi from 0 times x, that radius. What's the height? Well, it's going to be 4 minus x squared minus x. And shockingly enough, that's actually the answer. Oh, I need this point. So we do our super duper speedy algebra. 4 minus x squared equals x. X squared plus x minus 4 equals 0. Something's very wrong. Yeah, it doesn't help. X, I have to use a calculator intersection, is 1.562. So 1.562. Usually it'll factor out nicely. Again, I'm not going to do the calculus just in the interest of time. If you'd like, go for it. You should end up with 2 pi times 2x squared minus x to the 4th over 4 minus x to the 3rd over 3 from 0 to this weird little 1.562, and that should get you about 13.327 units cubed. Wow is all I can say. And we did this above. I've got one more here. It's a kind of off the reservation problem. When I say off the reservation, I mean it's just a bit much. It's a bit much, but whatever. We'll run with it. Mathematician. I'm drawing this 3D shape in a plane. He's got sine of 2x curve, and then he's got these semicircles that pop up out of the page. Hard to see. So, what's our area formula? That's the first thing to figure out. The area is going to be pi r squared over 2, 1/2 pi r squared. What's the radius? It's also going to be divided by 2 because that's a semicircle, that's a diameter. And we're looking at 2 sine of x, if I'm not mistaken. And this is squared. 2's cancel. We're left with pi over 2 sine squared x. Now, we just have to integrate that from 0 to pi. A lot of times I look at this problem and go, man, we haven't really accounted for this 2 sine of x. And yeah, sure we did. It's in the radius there. So from 0 to pi, pi over 2 pops out. Sine squared x dx. Go for it if you can do that with the calculus. I'm going to nint it, and I will get about 2.47 cubic inches. Again, it bothers me a great deal, and I have a third decimal place. I should. So there's some extraordinarily complicated mathematics. Do not try and do a handful of problems and say, yeah, this makes sense, I'm good. You really need to work at this to get good at it. For one of the few times in my life I truly mean it, happy mathing, because you're going to need it. Good luck.